All right, in this video, we're going to cover the second half of the PCB design process, which is the actual PCB design. So now we have our schematic, everything. So I went ahead and made sure everything's annotated properly. Everything has a nice unique value. And just go ahead. I've already committed the project. And so I'm going to go over to the circuit or rather the PCB. And yeah, I don't want to generate outputs. I want to import changes from Boost. And so this is going to be a list of all the parts and connections that I have. And I always like to validate. You can just go ahead and click execute, but you should get all check marks, green check marks, and then execute, and it should all stay green. And there's no celebration that it succeeded, so you just click close. You can actually, before that, you can unselect certain things if you don't actually want to import those. And so normal shift is so scroll wheel, if you got on your mouse, is uppy downy, shift and scroll wheel lefty righty, and control scroll wheel inny outy. And so this is going to be fairly small, so 08, 05 are kind of tiny. One thing that's nice is that you can press again, another short key is you can press the button 3, and that will give you the 3D model or the 3D view. And again, shift and right mouse button will move things around. So this circuit is clearly going to be dominated by the block terminals. Everything else is going to be relatively small. And so you can also, if you can get it in some all kind of cattywampus, you can press the button 0. That will bring it back, and then shift or scroll wheel around, zoom in and out, and then button number 2 will take you back. So this is the part where PCB design becomes much more kind of art than it is science. A lot of it has to do with how you want things to flow. For example, I know I want my V in on the left and V out on the right, because again, it's still somewhat of a convention to go for maybe small boards. You got your V in on one side and the electricity flows just to the other side. But again, it doesn't matter. It all has to do with your application. Maybe you want your input and output on one edge of the board, your switch up here or whatever. Okay, so also notice that these components, that they do have a correct position and an incorrect position. So they're both facing down. So this is the opening. So when I go to the the 2D view, I want to make sure that this is pin 1, this is pin 2, that this edge is facing out. So you can see that the pins are not centered on the outline. But in this case, I want to, then again, the same, if I select it and I hit the space bar, it will rotate. And again, so the problem with some of these components is that the center is not the center of the component. So whenever you do go to make a component, always make sure that your center is the center of the component, because when I go to rotate it, it rotates around the center. There are some components that they rotate wildly around a very large axis. So whenever it's so I would go back and edit this component and make sure that the center is the center of the component. But I'm not going to do that now. So again, this is weird just because you're the center is off to the left and below it. But I'm just going to place this roughly on the edge, and I'll place the V out later. Rather the V in later. But again, this is going to be the same problem. So make sure I select that, and I want this to face on the right, or to the left rather, just my other right. And I'm just going to roughly place it over there. And switch. See, now this is the center of rotation, the center of the component. So if I rotate it, it rotates around the center axis. And again, this is a component I'll most likely want on an edge. So we go to the 3D. You can see the switch faces off to the edge. Right now, I'm not really concerned about getting the size of the board correct. So it looks kind of funny. Like I've got this large 4" by 4" section, but we're going to edit the shape later after I've placed all the components. And a lot of this just has to do with figuring out the best way, best place to connect it. Now, one of the things you want to note is that these what look like traces are not actually traces. These are what's called a rat's nest. So this has to do with how things are connected. So you can, so if I hover over it, it will highlight all those that are connected. So for example, if I hover over the ground, you can see that all the other parts that are ground. So that tells you, it's supposed to be an aid for laying the components out. But you can always refer back to your schematic to see which ones are connected to which. But since this is somewhat more central, I'll want to bring this in, and yeah, so I forget which one's which. All right, so we've got the inductor, the capacitor, that's just going across the input. So let's go ahead and place C1 first. So C1 can actually just go right across the inputs. And so one of the things you want to look for is making sure that things aren't crossing. So I want to rotate that this way so that this is at the top and this goes off to the next component. And so one of the things that I really wonder about is, so this is going off to the side here. And really this switch should go at the bottom over here. Now I want to rotate that, press spacebar twice. And I'm just going to put that here, put the capacitor there. So now I don't have these wires crossing. And then so the input flows to this pin and then will flow off to this pin. And since this is connected here, and a lot of the other pins on this side go off, I think I want to rotate this 90 degrees and slide that in there. And so what gets connected to pin 5? Well, pin 5 is the inductor. So I'm going to move the inductor. So it makes more sense for me, to place this up here and then place the inductor there. So I can also move the silk screen. So yeah. Yeah, of course that's got to go to here and that's got to go to there. All right, so R2. All right, so I think what I'm going to do is stick with the inductor up on top here, so that pin will connect right to here. And this we'll have to figure out. Maybe I'll snake this around through the middle and connect that to here. So I'm not going to connect the ground pins together. I'm actually going to do that with what's called a copper pour. So R2 can kind of sidle up here. And let's see what else. So R2 and R1 form the voltage divider. Then R3 and the little LED are just the output. So I want to grab R1, and since these are connected and this one is connected to the output, I think what I'll do is just rotate this. So just rotate that and put it right next to that resistor. And I think I can move these a little bit closer. So you don't need to worry about the, oh, yeah. All right, so you don't need to, so one of the things that I forgot to mention at the beginning is that the PCB design, think of it as layers. So we'll have a double-sided board, but there are certain things like right now we're on the top layer. So all your layers are down here. So the top layer and the bottom layer are going to be where all your copper is, where the traces are, where the pads are. And the through hole, for example, are going to go from one side to the other. Your vias are going to go from one side to the other. This white, however, is not on the copper layer, so that is what's called the top overlay. So I can add, for example, I can add text in if I want to. So I'll definitely want to put my name and descriptor of what the board is. For example, over here, maybe I'll probably want to put, let's just put, let's see, just a big plus sign for positive. And I'm going to put that in the top silkscreen layer, or the top overlay. Silkscreen is just the white part. So if I click 3, you can see I haven't run any traces, but the L1, the text, the top overlay is on top of everything else. So we've got the top layer, which is the copper traces, and the solder mask, and then the top overlay or the silkscreen layer is printed on top of that. So this doesn't have anything to do, it doesn't interfere electrically. So if I run a trace under that, it's not going to cause a short circuit because it knows it's on a different layer. All right, just have a couple more components left. So I've got C2. I'm just going to move these a little closer so I don't have to keep scrolling back and forth. D1 and R3 are the output voltage, and C2 is just the output capacitor, or yeah, these are the output indicator. So I want to rotate that so that it's, so we've got ground. So I think I'm just going to somewhat put that arbitrarily there. So ground will just connect to that. Net is this just going to be, so pin 4 is the output voltage. So pin 4 is the output voltage. So that will just kind of basically shoot straight through. So that will go up here and then just go straight out to the, and so we've got R3, D1. And again, I want to use these. So what I'm looking at is all these connections. So how I want to have them close together, and I want to make sure that they're not crossing over. So if things are crossing over, for example, it looks like these are crossing over, but what I'm going to do, the way I'm going to connect it is that the ground is going to be a polygon pour. So it's going to be copper kind of all over wherever there aren't, and so that will connect everything together. So this won't be a problem. And then so now this pad goes up to here, so it makes sense to rotate this around the axis, and so this is connected up to there. And then my ground, that doesn't really matter. So this output, since these two are connected, I want those at the same level. So select that, rotate it. I'll just slide it up along, and then these two are connected, so I'll just move this around. I'll make sure that's selected. I'll rotate that, and now we'll just keep things nice and neat in a row. And now I can move this output V out closer. And actually I think I'm gonna move these up there. That. So you can also change the snap grid. So every time I move it, it moves in 5 mil increments. but I want that to be less precise. I'm going to move that, change that to 25, so I can line them up a little bit easier. And now I'm going to change that back to 5. So the reason I did that is because I want to add text here. So I want to make this plus sign. I want to make this plus size plus sign bigger. So here's the height. I'm going to make that, let's see what 80 looks like. And same thing, I'm going to change this to 80. Of course, I could just copy and paste, but and that will actually go up here. And of course, I want to have a little bit of text, so I'm going to add that into the top layer. I want to put what it is. So this is, I also want to make the text smaller, so I'm going to change that to true type font. And I'm going to change that to 5-volt boost. And we'll call it version 1. And you can also, before you bring it in, you can hit tab and change all the various features, change it to true type. And we'll put today's date. So I know when it was made. All right, so this is the majority of the work. Since we've taken the time to lay things out as well as we can, running the traces should just flow. And so the shortcut for running the traces is R for route. Then the same little cross pattern comes up, or you can come up to here where it says, where it just says route, and just select that. Now we are on the top overlay, so that will, no, I lied. Just kidding. So we don't want to run the traces for any of the grounds. We're going to do that last. So we're just going to start off here, and we're just run traces. And we're just following the little rat's nest wires and just connect it. So I connect it once, then it wants to continue, but since there's, this just has 2 connections, I'm just going to right click, and that'll get me out. If I right clicked again, that will get me out of routing entirely. So I'm going to go back by pressing R, and then what I have to do is connect that and connect these. You can see as I'm going to zoom in, I select on the center, it has a little round circle. So as, all right, so we can trace this. So let me zoom in so we can see this a little bit better. Now, if it starts off by going at the angle you don't want, like if you want the 45-degree angle to face the other way, you can just press the space bar, and it will rotate it. And as I move it closer, we'll just make that. As I make the connection, the rat's nest begins to disappear. And cut that. You can see as we run traces that it won't actually connect. The software won't let you connect to something that's not supposed to be connected. So it's if you make a mistake at this point, it's might be something that's set up incorrectly. And we're going to run that trace to there. And this goes to the other side of the inductor. All right, at this point, looks like I've got everything except ground traces run. So now I want to go up and change the board shape. So I'll go up to board shape, and I want to edit the board shape. That brings up these little dots, and it makes everything a little bit gray. So your inclination would be to just grab these dots, but if you do, it actually bends at that point. So what we want to do is we want to go over to where it just changed to the single direction arrow, and then grab that, and that will drag the entire side down. We'll just bring that relatively close. Again, we'll do that with all the sides. And once you get close to it, you can, to the final size, you can zoom in and just fine tune it. So this bottom one, I want to move that a little bit closer. And that looks pretty good. So just click outside. Now we're getting pretty close to being finished. So I want to go, so what I want to do is to show you how we connect all the grounds together. So we're going to use a polygon port. All right, so you go up to click the polygon, and we're going to stick with the solid and all the rest of the default settings. Now we want to select the ground net because we want to click all of the grounds together and nothing else. And we want to change that from no net to ground in the name, just to have nice and consistent. And we'll go up to the corner, and where it changes to a bubble, we'll want to left click that, stretch over to the other corner, and third corner, and the last corner, and then out somewhere outside, just right click, and then that is all of the ground. So one of the things that might happen is that you could, in theory, let's see if I zoom in, if I move this ground pin for this one resistor, it could be isolated, could be floating. So for example, you've got this little kind of little sliver that the trace could get through. But it's connected. You could actually have just this isolated ground. You would have to have like some kind of via and drop it down to another layer. But it looks like everything's connected. I don't see any rat's nest wires that we missed. And as our almost last step, we want to add the outline layer. So when you get this manufactured, the manufacturer needs to know where to cut it out of the larger panel of boards it's making at the same time. To do that, we'll go up to board shape and go to the very descriptive and obvious where it says, hey, this is where you create an outline, create primitives from board shape. And that's a generic thing. We can do multiple things with it, but in this case, we're just going to create an outline layer based off of the shape of the board, and we're going to put it on the outline layer. And so we don't have to do anything else here. So we don't have any things cut out, and we just click OK, and then it pops up a nice little outline layer. So now that when you manufacture it, the people will actually know where to cut it out from your board. And this is one of those steps that is forgotten fairly easily. But the manufacturers will let you know that they don't know where to cut it out, and they'll ask you to resubmit it. All right, and then as a last step, you always want to do a design rule check. Even if you haven't set it up specifically like we have here, you still want to run this. So we're just going to click, and we're doing all of it, and we want to do a design rule check. Now it'll come up with a whole bunch of errors that it's just for the silk screen, but we haven't adjusted any. So the ones, if you're just doing a real quick, dirty board, you don't really care about having 0 errors. You want to make sure you don't have any unrouted net constraints. So that means you haven't missed anything, and you want to make sure that you don't have any short circuits. So these are the things that will affect the actual functionality. The rest of these have to do with preferences and manufacturability. It all has to do with the manufacturer that you go to and what their tolerances are, what they can actually make. But in this case, silk to silk, that doesn't really matter much. Silk to solder, minimum silk solder sliver. Again, these aren't things that we necessarily need to fix. So we don't have any errors that are going to cause a problem. So that is the last bit. And so just to check it out, what it looks like, we can click the 3. So one of the things that I might actually want to change is that I just noticed is that the switch is not actually kind of poking out the side of the board. That might make things for turning it on and off. Maybe I want to actually add a text in there to say in this position it's off, in this position it's on. So I'm actually going to do that now. So I'm going to switch back to 2D mode. And first off, I want to select the switch itself. And then I'm just going to just drag it straight and right to the edge of the board. Now it's going to ask me, since I'm now over the copper of the polygon pour, I'm actually going to just say make it unpoured. So it's not, so the polygon port is still technically there, so that the grounds are still showing as connected, but it's just not showing. And basically what I want to do is, just going to drag this. Yep, just kidding. So basically what I want to do is just route back to this point. Click that. And click that. Just kidding. All right. So I've reconnected the switch. And so let's just check that. So the switch is nicely on the edge. I still need to add the text. So I want to give myself a little bit of space. So I'm going to move that over here. And I want to add text. I want to add, see, you can also add text into any layer. So if I add this in the copper, there's a good chance I might, if I place it, for example, over here, and it might short it out. You can actually do, if you do this, if you know what you're doing, you can put it off to the side. This will actually appear under the solder mask, and it can have a different effect. But we want to make this nice and visible, so we're going to click Tab, and I want to make sure this is not on the top layer, but on the top overlay. So I'm going to select that, and then I'm going to write off, and I'll keep it at 60 mils. And so in this position, that's off. And without pressing escape, I'm going to press Tab. I'm going to put on. And click OK. Not really enough space. So here, I don't want the text to be over top the solder pad. So basically, I think what I'll do, just put that there for now. And I think what I want to do is move the switch over to give myself a little bit more space. So I'm going to slide that over. Now, there's plenty of space to move that in. Now I'll slide that up a little bit more out of the way. Those are on the nice level. So now it comes up with errors, obviously because I've forced it to sort of be connected to the wrong things. Now one of the things that's pretty nice, I can just, to fix this, I can just click this, click that, right button, boom, the rest of it goes away. Now this is going to be a little bit more work, so I'm going to hit backspace. I'm just going to delete this a bit more, and then reroute to those points. And right there. And that should fix it. All right, so now I want to make sure I do a repour all. Make sure the polygon goes back. And I think, yeah, move that over just a hair. All right, so if I go to 3D mode, all right, I got my off and on positions. It's looking pretty nice. And date, well, it's all looking pretty good. So 0, 2. Now, of course, I've made some changes. Now, I always want to go back and do my design rule check again. Now I'm going to have more videos of actually what the design rules mean and the significance of it. So now I've got 2 more errors, but that's because I put text. But again, I just want to make sure there's no short circuits and everything's connected. So this is just silk to silk. This is just the, I could go in and change the rules just to make sure that these go away. But I'm not going to bother doing that. It doesn't affect the actual function of the circuit. Now, just make sure I'm not missing anything. Sometimes I'll, things will be in the wrong place, or, like this top layer is getting chopped off by something. All right, well, I'm happy with that. And so that is the end of this video. The next video will cover the actual the process for getting it manufactured, actually generating the output files and then going to a manufacturer.